In this lecture, we're going to see how we can use parallel lines to find the equation of another line. So let's take a look at the problem there. Find the equation of a line that goes through the point 2,9 and is parallel to the line y equals 3x minus 11. So we're supposed to find the equation of a line which is not this one. We know that it's parallel to this one, but it's not the same. So what do we have to remember? It is the equation of a line which is given like this, provided that you have one point, in this case 2,9 is our x1, y1, and provided that you have the slope. Now, it looks like we don't have the slope right now, because we usually need 2 points to be able to use the slope formula. However, that's the part when the parallel line comes in. If we know that this line is parallel to the one I want to find, then this line will give us the slope. The slope is actually right here because the y is isolated, the slope of this line that we were given. Now, because the other line is parallel, the line we want to find is parallel to this one we were given, then for that reason the slopes are the same. In other words, here the y is isolated, so we know the slope m for this particular line is 3. It is the number accompanying the x. Now we want to find the equation of another line that is parallel to this one, and for that reason the slopes are the same. So that's the slope we're going to use here to find the new equation, and we're going to use this point 2,9 as the x1, y1. So let's see what the equation will look like. Y minus y1, which in this case is 9, equals the slope m. The slope is 3, which came from the line we were given in the problem. 3, as usual, the parenthesis, x minus x1, which in this problem is 2. So now we continue solving, and we get y minus 9 equals 3x negative 6. And to finish up the isolating, we put 3x minus 6 plus 9, which then becomes 3x plus or negative plus 3. Okay, so what have we noticed here? We have noticed that these two lines have the same slope here, 3x and 3x. Why is that? Because they're parallel. Okay, because they're parallel, they must have the same slope. What changes, if you pay attention here, is the y-intercept, which on the first one was negative 11, and here it is plus 3. So that's another way to recognize parallel lines. Provided that the y is isolated, it doesn't really matter what the y-intercept is. Okay? So to see it now in a way that we can remember, all of these lines are parallel. So let's see the examples here. Y equals 3x plus 1, y equals 3x negative 10, y equals 3x plus 6. So the y-intercept doesn't matter. It is the slope that counts to check that the lines are parallel. So you can have as many parallel lines as you want, provided that they have the same slope. So if we have another line, for example, y equals negative 6x plus 2, then it's not parallel to this one, because here the slope is negative 6, while here it is 3. But we also know what a parallel line will look like, because it's going to be something like this. Y equals negative 6x plus 5, y equals negative 6x plus 4. Okay, so as long as the slope is the same, we know the lines are parallel. And if we want to find another equation, then all we need is a point if we already have a parallel line. So as an exercise, you're going to try to come up with your own set of parallel lines, and you will also try to solve the quiz. So go ahead and pose 3 examples of parallel lines using the information you learned in this video, and also check that quiz to make sure this information goes straight to your subconscious, where it's supposed to be, so that you do your best on the test.